Let's talk about use of time in Python. One of the most frequent usage of timing functions in any programming languages is to delay execution of a task. Potential scenarios are, for example, when you need to create a delay between user input and some action. For example, your user presses a button, and then after some time, if the user doesn't cancel the action, then you start executing that action. Or if you have a query to external resource and that resource returns error, you want to retry the access, but you want to delay retry by some time. In order to organize such delays in Python, it is convenient to use time module and specifically time sleep function. For example, if we execute this code, then it will be delayed by 1.1 seconds exactly. Well, maybe not exactly, that depends on the implementation of the delays by operating system. And in some cases, for example, Windows likes to wake up the task earlier than this specified amount of time. And you can only rely on this time to be with precision of +1 second in most of the cases. Let's use this timing function to create a countdown, or actually count up timer. And let's count up 10 seconds starting from 0. To do that, we will use a loop, and in this loop we will use time sleep function to delay every iteration by 1 second, and we will print the iteration number at the end of the loop. Please note the extra spaces here that are used to replace any characters that might have ended up from previous iteration. And we need to have them because in this case we are not going to use new line after end of each line. And we will prevent Python from going to a new line. And instead we will force it to use carriage return character at the end to force the cursor to return to the beginning of new line so that we can replace it. And if we execute it, you can see that it starts counting up, and once it reaches 9, it will stop and the program will be completed. As you can see, the timing is approximately 1 second per change, and this is precise enough for interaction with humans or external services, but maybe in cases where you need precise timing of your events, you want to use another library. For example, datetime. We have already used datetime.now, and in this case we are going to import datetime as dt. And if we run this, you can see that it prints out our current time. You can also note that this datetime object contains individual values for year, month, day, hour, minutes, second, and microsecond of every moment. Instead of using now, we can also manually specify the value of the datetime object, for example, by doing this. Here we use keyword arguments for year, month, and day. Similar keywords are available for hours, minutes, seconds, and microseconds. And this works in creation of a midnight pointer to 24th of December 2021. Similarly, we can use this function with positional arguments. So we just pass the year, month, and day sequentially as they are printed out here in this format. Finally, of course, we can save the values from datetime object into variables, and we can use dir to list all possible functions and properties of the datetime object. The ones that start with double underscore are not supposed to be used by us directly. Those are usually technical functions and properties, but in this case, everything else is something that we might be interested in. And for example, things like year, month, and so on. These properties can be used directly to access the values from that object individually. And then ISO format function that we're going to talk about right now is used to display this datetime object as an ISO formatted string. ISO formatted strings are very commonly used in different information technology systems where they are acting as a standard form for machine readable input. So you can see it's not really human friendly format, but if you replace T with space, then it becomes a little bit more readable for humans. And for machines, it is perfectly readable because it has all elements separated by some special character. In this case, year and month and day are separated by dashes, and then T separates date from time, and time is separated by colons, and then dot to separate seconds from microseconds. And the beauty of this format is that it does not have to be specified in full. So if you just specify year, then it will point to the 1st of January midnight of that year. If you specify year and month, then it would be the first day of that month, and so on. We can use the accessors that we have described previously, that we have listed with dir function, to print out the formatted text manually. And you can see with these commands, with these formatting strings, we can actually print out human readable output out of the same datetime object. And the only important thing here to notice is that weekday is not a property but a function, and in order to get weekday of the corresponding week, we need to actually call it, not just write dot and then the name. And here, as you can see, Monday is numbered as 0, and Tuesday is 1, and Sunday is 6. And this way you can, for example, implement checks for Sunday being a working day or a weekend. But this is about accessing and creating objects and reading the values. How can we modify the existing objects? One approach is to use replace function, and replace function allows you to directly change values of the object. For example, we had our sum times that was set at hour 15 minute 29 something, and we replace values for hour, minute, second, and microsecond to 0, and we get this object that refers to the beginning of the day, of the same day on which this object has been created. In a similar way, we can use this replace function to modify the value that exists already in the object. So we can take the object name, the value, for example, for year, and set a value for years that is +1 from current year. The only problem with this approach is that it doesn't really work well for days and months. For example, if you are going to add 1 month, November, that would be working fine. But if you are going to add 2 months, you will end up with an error message that specifies that, okay, your month is now 13 and it's not in a valid range. And this is a problem that you can, in theory, mitigate by, for example, adding a modulo operation like this. But even that is not really the easy solution, because first you will have to subtract 1 from the number, because the values are starting from 1 and not from 0. And then you will need to add 1 back. And this will work, so it will set the month correctly to January. But the problem now is that the year stayed the same, so we didn't wrap the year correctly. And to avoid all these problems, there is another mechanism in Python that is intended to handle time intervals. So let's consider the following example. Okay, if we run this, we can see that it first creates a new datetime object, start time. Then it replaces, in a similar manner as we did before, hours, minutes, and seconds with zeros, creating a reference to the beginning of the day. And then we compute delta. Delta object is of type datetime.timeDelta, and this is basically the difference between end time and start time. So the larger number goes on the left and the smaller one goes on the right. And as you can see, our time delta is printed out as 15 hours 35 minutes and so on. We can also use delta.total seconds, as we did before, to compute the amount of total seconds that have passed since the beginning of the day. As you can see, this is quite a huge number. And finally, after we have computed this delta, we can also use time deltas to apply changes to existing times in a similar way that we wanted to do here. But let's use this time delta object to modify our end time. So we will take end time and we will apply time delta of 60 seconds. And as you can see, it correctly incremented our end time to 1 minute of 0th hour. And if we were to modify this example and to add, and let's add 60 days to represent the interval of about 2 months. And we will get the date that is correctly set on the 9th of January 2022. So it wrapped both months and year after we have modified the day. The problem here is, as you have noticed, it does not really work with month. So we need to specify the exact amount of days that we want to be added. And the reason for that is because when you specify addition in form of months or years, we really cannot tell exactly how many, the object cannot tell exactly how many days we want to add, because what does it mean to add 2 months? Is it a 30-day month or 28-day month or a 31-day month? So yeah, then it gets a little bit messy. In such way, you can modify basically days, hours, and minutes and seconds. But then for largest numbers, you can use replace to modify years. And for months, you need to specify amount of days instead. Okay, so far we have been dealing with just time. But the problem is that time is not absolute concept. We don't have any absolute time except for universal coordinated time, and we don't use it in our daily lives. And as you have seen, the time here that have been printed out by this function matches my system clock, which means it's local time. And this is Helsinki time or UTC +2. In Python, time objects can contain information about time zone to which those time objects are referenced. And for example, we can use these constructors. They don't have the information about time zone yet. As you can see, the information is just time. And even though it says here UTC now, it does not really set the time zone of that now to UTC. But it correctly prints that now in UTC it's 1340, not 1540, which is local time. And this is what is called in Python naive local time. In this case, we can print out the .tz info or time zone info, and you can see that it is set to none. And this is a property of a datetime object that basically defines if this is a naive object or if it is bound to a specific time zone. So how can we make objects that are bound to a time zone or time zone aware time? Let's see these examples. Okay, if we run this code, we can see the following. So first of all, we have created simple local time using dtNow constructor, to which we have passed another optional argument, which is tz, and we have used tz model to get local time zone using this function. And as you can see, the first object is printed out correctly, specifying local time and correctly specifying local reference to UTC for time zone. Now, second option is to provide the offset from UTC for local time zone manually. So for example, we can say that we want to create dtNow object, which will have a time zone value passed to it as an argument, and it will have time delta, which is necessary to create a time zone object, with offset of 2 hours. And it creates the same amount of time. The minor difference here is because the code is run sequentially. Finally, the last constructor is used to create manually a UTC time. So we create dtNow, which gets time zone object, and for that time zone object we specify hour of 0. So we want to get UTC time that is representing current moment of time. Please notice that we are no longer using UTC now here, because that would make no sense. From perspective of time zone aware time, there is no difference between now here and now in UTC. The only difference is that for one object we will have time zone set to 2 hours offset, and for the other to 0 hours offset. And as you can see, the difference between UTC time and local time when computed by our subtraction operator is actually close to 0, and this is basically the execution time that it took to complete between this line and this line of the code. Now, what do you want to do if you want to actually convert time that is provided to you in the time zone aware format when you want to convert it to naive or vice versa? So here are two calls. The first one takes a naive time, which is produced by dt.now, and then it uses replace function to create a time zone aware object by providing correct time zone for that time. If we had used UTC now here, we would have received a wrong time. It would not have been corresponding to the current moment of time when we run this line. The second line, on the other hand, goes in reverse. So it takes a dtNow object that is created with proper time zone here, and then it replaces the time zone info part of that datetime object with none, converting it into time zone naive object. And as you can see, the outputs are as expected. So for the first one, we have proper time and proper time zone, and for the second one, we get proper time with stripped time zone information. Okay, this is good when you are converting within the same time zone and you're only interested in converting local time between naive and time zone aware offset. But what if you want, for example, to get time zone naive value for a different time zone, not the one in which you are currently present? In such cases, we can use the following. If we run this, you can see that now we use UTC-now object because we want to get some incorrect time. And we are going to replace time zone info with time delta hour 0 offset of UTC time. And as you can see, this whole construct creates correct timing. So it creates reference to the current moment of time using UTC time zone. Okay, now what if we need to convert this time in non-local time into our time and then make it time zone naive? So the first step, we are going to use sTimeZone function, and we will supply the new time zone which we want this datetime object to be present in. And we pass local time zone, so we get local time, but it is still the same moment of time. Finally, we use replace to remove time zone info, to set it to none, to get time zone naive object. And with this, you can convert not only to local time, but to any time zone. For example, I will use this time zone information and time delta to convert this time to, for example, UTC minus 10. As you can see, it starts from 1348, then it goes to 0348, which is correct, but it has time zone still, and then it removes time zone offset completely. And this is very useful in some cases where you will have databases and different sources of data providing you timestamps in time zone naive mode. So you will have to first convert this information into appropriate time zone. The problem with having a mix of time zone naive and time zone aware times is that you are not allowed to compare time zone naive and time zone aware datetime objects, because for obvious reasons one is not aware of what is time zone, and you cannot assume that they are in the same time zone as the other object.